You already have a basis of understanding for Coulombs Law. It looks very similar to something that you were able to demonstrate your mathematical and computational thinking. In Learning Objective 1, you demonstrated your mathematical and computational thinking when you did word problems related to the universal law of gravity. Over r squared. So this problem should look very familiar to you. If I told you what M1 and M2 and R is, you should be able to calculate a force. G is just a constant. It's the same G for all the equations. Calculating a force. This unit is on non-contact forces. We feel the force of gravity every day, so it's holding us down to the surface of the earth. We also feel electric forces. I mean, they're all around us. I mean, they're in the light bulbs, in the smart board, they shock us when we use our fingers. These forces are very real. The thing about electric force is it's much, much, much stronger than gravity on a per mass basis. So in order to have gravity, you have to have a lot of mass. For small objects, even like asteroids, there's nothing. You can't live on an asteroid. There's just not enough mass there. But electric forces, we can see that very easily, right? Who's got the sweater today? Someone got a good sweater today? I don't know, let's do the hair trip. If we want to see the force of electricity, it's really easy to see. I mean, look at that. I mean, that's like popcorn, right? We can see electric force really easy with just a small number of charged particles. But electricity is a little bit different than gravity. There's a couple of differences. One of them, I just explained that it just takes a small amount of charge in order to force something. But also, electric forces have a positive and a negative, and that's what we learned in our last unit, in our last learning objective, is that there are these repulsive forces and attractive forces, depending on the polarity, if you will, of the charge. We don't have positive and negative gravity. If we did, we would have anti-gravity, and these cool hovering vehicles that go across, or skateboards, or hovercrafts, that would be a reality. But we don't have anti-gravity. But the formulas for the force of electricity and the force of gravity are so similar that Einstein recognized this, and he died trying to unify the forces of electricity, of magnetism, and of gravity. Let me put up the force of electricity equation. Looks very, very similar. The universal law of gravity states that if I know the mass of the first object and the mass of the second object and the distance between them, then I can calculate this force of gravity. The electric field force says that if I know the charge on one object and I know the charge on another object and I know the distance between them, then I can calculate the force of those, the force of the electric force. What you're going to do today is I'm going to take you through a variety of experiences, and at the end of the day, you're going to be able to do a problem like the example problem that I have on the board. This may be one of the easiest learning objectives that you have to do. We'll get it done.